My name is Jack Hernandez. I'm actually a fourth year undergraduate at Texas Christian University. And here is my project concerning searching for twins of PTF11kx. So PTF11kx is a type 1a supernova. Type 1a supernovas are the result of explosions of white dwarf stars. They can often be used as measuring sticks in a lot of astronomy research due to the fact that they can be standardized with one another. They've been used in searching for the expansion of the universe and also in research in dark energy. And they come from mainly two ways. The first one being the double degenerate channel, where in that binary star system, both of the stars are white dwarf stars. And as white dwarf stars have little to no hydrogen, as they collide and become a type 1a, there is no circumstellar material. And the other scenario is the single degenerate channel, which is when in that binary star system, only one of the stars is a white dwarf star and the other star could be a main sequence or a red giant, for example. And as a main sequence or red giant would have that additional hydrogen plus with other material in it, as the white dwarf is collecting all that material and taking it, not all of it falls into the white dwarf. Instead, it sort of ends up branching off and ends up hanging around the white dwarf in its vicinity. And so while that white dwarf then reaches its mass limit and then ignites, it would then collide with that circumstellar material that is found around it. And one of the biggest results from that is what it looks like in luminosity terms. So here in figure 4, it is comparing PTF11kx in the green to a normal type 1a, which is in the orange, which is the 2011 FE. And these two have not been standardized with each other, but they still exhibit the same behaviors as we would expect from a type 1a. So as they, when they ignite and now reach their peak brightness at some time, they would then rapidly decrease in luminosity as time goes on until for a normal type 1a around day 80, 90, there is no further luminosity and then it goes straight to 0 and remains at 0 past in those later times. That is because all the ejecta has already been thrown out and so there is no more additional luminosity. For a normal type 1, while for PTF11kx, it ignites, it peaks at some time, and then as it rapidly decreases around day 80, 90, it instead pivots and stagnates suddenly. There is still additional luminosity present within the supernova, and it continues like that until for very late times, all the way until day 400, where it still has not reached that 0 luminosity. And this is due to that supernova ejecta being tossed out and then colliding with what is around the circumstellar material, creating that additional luminosity and that additional interaction. And since PTF11kx's discovery, there hasn't really been one like it. It is one of the few type 1As that do present circumstellar material. So what my project is about is looking for type 1As that are like PTF11kx that do have that circumstellar material. And so we did that using the Zwicky Transient Facility data in the R band to then create light curves from it using force photometry from the ZUDS pipeline. And what essentially it does is that it creates an image at a pre-supernova explosion at some time as shown here, and then creates several images after explosion, and then subtracts the two to create a flux. And with the flux, we're able to convert it to luminosity. And we did this for several supernovas in the data years of 2018, 19, and 20. And these are just some examples of what came out of it. So here are two supernovae within our sample that had different qualities of data, because a lot of the data depends on multiple factors, such as if there's an AGN present, if there's host galaxy emission present, and other objects in the way of it. So here on the left is one of the better parts, one is the better looking light curves. So it's being compared to PTF11kx and a normal type 1a. And as you can see, it's still like very sort of linear. There's no oscillation, there's no like sporadic points everywhere. The error bars are very low. And then the filled in points represent data points that show above 3 sigma confidence. And so this is just to show like very good quality data they were able to obtain of this particular supernova. And here on the right is one of the lesser quality data that we got of this particular supernova, with all the points looks basically everywhere, essentially paint splatter. And again, the filled in points represent data points of 3 sigma confidence. And so from ones like the right, it would be very, very difficult to distinguish if this particular supernova would be like PTF11kx or not. And so with that in mind, ultimately we had a sample size of about 26 candidates. And of those 26, 6 of them were potential candidates that could be 11kx-like. Here is a chart plotting all of them over in comparison with PTF11kx and the anormal type 1a. And in the filled in ones are our potential candidates. But however, due to further investigation, all 6 of these have been ruled out for a variety of reasons, such as an AGN being present in the host galaxy, or there's contamination from the host galaxy, or it's very close to other objects, so it's very difficult to distinguish where exactly the luminosity is coming from. But even though we had just 26, there's still like a light at the end of the tunnel. With what we found with these 26, we were able to then constrain it and determine like what it all means. So this is just like, in this chart right here, it is just a histogram of the luminosity of which supernovas we can detect at a certain luminosity, and if we would be able to determine if they're 11kx-like at all, given the sensitivity of our telescopes. So the green bars here represents the luminosity of PTF11kx. It's a very low, and then the one right here represents 10 times the luminosity of PTF11kx. So what essentially it is saying is that at this given luminosity, we would only be able to determine only one supernova within our sample if it would be PTF11kx-like or not. And as that luminosity increases to that 10 times part, at supernovas at this luminosity, we would be able to determine if they would be or not. And it would be about 20 or 21 from our initial sample. And the outline just represents if it has more than half of time periods have 3 sigma confidence, and the filled in pink is just if 3 or more have 3 sigma confidence data points at those times. So it's just something considering with our telescope, and it's valuable to see. And it also helps us also constrain the fraction of type 1As of like a general population of type 1As that would be 11kx-like, PTF11kx-like at a given luminosity. So again, the green bars represent the luminosity of PTF11kx. And what essentially this is saying is that at a given interaction luminosity, this is how many percent of supernovas would be PTF11kx-like, and it centralizes as luminosity increases around the 25-27% range.
3 minutes
So
left.
within our sample of 26, we are able to deduce this fraction. And so the biggest takeaways is that, in summary, we use the ZTF. We use ZTF to identify 26 candidates to comprise a sample and then create light curves using the ZUDS pipeline. And of those 26, we found 6 potential candidates, but upon further investigation, they were ultimately ruled out. And we were able to determine a constraining fraction of within our from our sample to then apply to the general type 1A population. And so for further work, we would like to increase our sample size to further constrain this fraction, and also use the upcoming project LSST to obtain higher quality and larger quantity data.
Thank you so much, Jack.
Jack, that's a nice talk, and I find it fascinating just how rare this PTF11kx is. The 26 candidates that you sort of started with as your sample, that's 26 out of, I'm guessing, an even larger sample. Is there, can you sort of give some sense of like just what the starting point was even for getting that sample of 26?
Mm-hmm. So the initial sample was about 140. They were determined from ZTF due to that it was like 91T like due to its brightness and also how far away it is. And so that's how they were determined. And just depending on a variety of factors, such as does it even have enough data to be able to create a light curve from. So some of them, it would only have like 2 weeks worth of data. And then because of quality purposes, we aren't able to use that. So there were like criteria of like how many like flag points were there that we needed to like look for further. And then also like if it had sufficient amount of data. So if it had more than a month, we focused, that's what like made it into the 26. And yeah, those were the big components.
Great, thank you.